In the last session, we had discussed about the properties of addition and subtraction, but we had not taken up few the word problems based on the addition and subtraction. I'll just be taking few of them, and then we move on to the properties of multiplication of rational numbers. The first one being the sum of two rational numbers is minus 5.5 minus 3 by 5. I'm sorry, minus 3 by 5. It's given if one of them is minus 9 upon 20, find the other. So let us see and write down in a very general sense. It says there are two rational numbers, the sum of whose is minus 9 upon 20. One of the number, minus 3 by 5. I'll erase this. I made a mistake here. I'll just write down the one. It says 3 by 5, and one of them is given to be minus 9 upon 20. So let us assume the one which is not given or just supposed to be found out, find the other one, be x. So we can find x by moving 9 by 20 to the other side, thereby making it minus 3 by 5 plus 9 upon 20. If I take LCM of 5 and 20, that will be 20, and 20 divided by 5 is 4. 4 multiplied to minus 3 is minus 12. Plus 20 divided by 20 is 1. 1 into 9 is 9. So thereby giving us minus 3 upon 20. So the other number is minus 3 by 20. I give you another similar question, but will not be solving it and will leave for you to solve. That will be what should be subtracted from minus 3 by 4 so as to get 5 by 6. Just simply try to make yourself understand by making the boxes as I did in the previous question, so that it becomes easy if you assume one of them to be the one which is not given to be x, and then carry on for finding the other number. Okay, we'll now be taking up the properties of multiplication of rational numbers. When we do multiplication of rational numbers, we may find out the multiplication by multiplying the numerators separately, and by then multiplying the denominator thereby. So the properties of rational number I take up in another screen thereby, and the first one is properties of multiplication. First one is closure. That means if I multiply any two rational number, I'll get another rational number. Closure, it is closed under multiplication. So A by B, when multiplied to C by D, the product is also another rational number. Let's take up commutativity. It is commutative. The multiplication of rational number is commutative. That means I can multiply them in any order. I can write A by B multiplied to C by D will be C by D equivalent to when I multiply with A by B. We can take up an example to explain this. Suppose it is 3 by 4 when multiplied to 5 by 7. And then, it will be, on the other hand, if I am taking C by D as 5 by 7, that will be written here first, and then A by B will be 3 by 4. So it is 15 by 28, and here also it will be 15 upon 28. The last, say, next one is about associativity. Yes, under multiplication also it is associative. Oh, I think I missed writing it. Instead of C, I wrote it here S. Can just ignore it, that spell mistake there. If I am taking three rational numbers A by B, C by D and E by F, then I can multiply it as A by B multiplied to C by D multiplied to E by F. That will give us the same answer if I do A by B, then put the rest 2 in the brackets. It is C by D into E by F. Right. Let us now take up another example. I'll take up A as I did in the previous one. 3 by 4 will remain A by B. C by D will remain 5 by 7. I again can take 1 by 2 as E by F. So I put this in the bracket. On the other side I'll put 3 by 4 here and the rest of the 2, that is 5 by 7 and 1 by 2 in the bracket. That's giving me 15 upon 28 multiplied to 1 upon 2. On the other hand, this is 3 by 4 and 5 by 14. Okay. Now this is 15 upon 28 into 2. I think this is 56. On the other hand, 3 5s are 15 by 14, 4 is also 56. So we have proved the associative property of multiplication of rational numbers. We'll be taking up questions. So let us do the distribution of multiplication over addition. I write it here. Distribution of multiplication over addition. What it says, let us first understand and then I take up an example. It says if we have any three rational numbers like A by B, C by D and E by F, then A by B multiplied to C by D plus E by F is equal to A by B first multiplied to C by D and A by B multiplied to E by F. Let us see with any three rational numbers. I'm taking A by B as 2 by 3 multiplied by C by D I'm taking as 3 by 5 plus E by F let's take as 7 upon 10. So this should be equal to, if we solve the one in the bracket first, should be equal to 2 by 3 when 1 multiplied by 3 by 5 plus the same 2 by 5 because that's A by B multiplied to 7 by 10. Let's solve the one inside the bracket here. So if 5 and 10 I'm taking, 10 is the LCM. 10 divided by 5 is 2, 2 into minus 3 is minus 6 plus 10 divided by 10 is 1, 1 multiplied to 7 is 7. This, if I'm getting, this is getting cancelled, they were leaving it as a minus 1. So it is minus 2 by 5 plus, here also it is getting cancelled by giving a 25 plus 7 upon 25. Now the one here within the bracket is actually 1 by 10, but here we have to take an LCM, one LCM. So 25 is the LCM. 25 divided by 5 is 5. 5 into minus 2 to minus 10 plus 7 I'm getting. I did a mistake somewhere, I think so. No, this is giving me, yeah, I'm right somewhere. 7 by 25, and then do I be getting something somewhere? It's minus 5, 5 is 25. Here is minus 2 by 5, so I'm getting here is actually a 5, so it is 1 by 15 I'm getting, but the same I'm not getting here, so I might have made some mistake somewhere. So it is minus 2 by 5 here. Did I make any mistake? Oh yes, it was not 2 by 5 here, it was a 2 by 3. A by B is 2 by 3, which I made a mistake. I'm really sorry for doing so. It was an error. So thereby getting this as 15 again. Oh, so whole of this thing will also change because I have a 15 here, so it is minus 6. So it becomes 1 by 15 again. Because that's a property we need to, show the left hand side to be equal to the right hand side. And so this is distributivity of multiplication over, addition. There also exists a multiplicative inverse, or we call the reciprocal of a non-zero rational number. And that means every non-zero rational number like a by b, there exists another rational number such that if you multiply those two rational numbers, they will be 1. That means the reciprocal. If I have a rational number a by b and then I multiply a b by a to it, only then I get 1a. So this is called the multiplicative inverse. The reciprocal of a rational number is the multiplicative inverse of the given rational number. We'll continue more in the next session because we haven't taken the questions of multiplication yet, and then we take up the division of rational numbers. Thank you.